Welcome to the homework solution tutorial. This is on 3C, quadratic formula, but we are going to be covering 5, 6, 7, and 8. 5, 6, 7, and 8 asks us to find the discriminant. You're going to use it to describe the number of roots / solutions that the quadratic equation has. Okay, I would like to remind you about the core concept that we learned in class. The discriminant is the stuff inside of that radical. So the discriminant is basically b squared minus 4ac. Based on the value of b squared minus 4ac, you can determine if it has 2 real solutions, 1 real solution, or no 0 solutions. It depends on what that b squared minus 4ac is. That b squared minus 4ac, if that is positive or greater than 0, it has 2 real solutions, 2 roots, 2 x-intercepts. When it equals to 0, it has 1 x-intercept, 1 real root, and 1 solution, 1 real solution. And when inside that radical is a negative, it has no x-intercepts, no real solutions, and no real roots. Okay, so we're going to use that idea to help us do this problem. Okay, so the discriminant is always in this format of negative b of minus 4ac. So let's just plug it in. So b here is 3, so 3 squared minus 4, a is 5, and c is, we should put this in standard form first. Okay, so let's add 1 to both sides. That is better practice, putting always in standard form. 5a squared plus 3a plus 1 equals to 0. Now let's label my pieces. A equals to 5, b equals to 3, c equals to 1. Now we can plug it in. So this is 3 squared minus 4, a is 5, c is 1. 9 minus, this becomes what? 20, 21? No, wait, 20. 9 minus 20 is negative 11. So here it looks like it has no real solution. Okay, I can always double check this. Okay, if I go to Desmos, so let me pull up Desmos here, and I'm going to actually graph this. Okay, so 5a squared plus 3a plus 1. That should be an a. Let's see, can it? They don't like a, so let me just make this x. Okay, perfect. Now do you see this? If I graph this, do you see how there's no x-intercept, right? So there are no real solutions here. Okay, that's how I can always double check. All right, so I'm going to do that for all the other pieces. Okay, let's look at 6. Here's the equation of the discriminant b squared minus 4ac. Let's make sure this is in standard form. So add 125 to both sides. So this gets you 5b squared plus 50b plus 125. All right. Oh, you can actually factor out 5 if you want, if that makes your life easier. So this becomes b squared plus 10b plus, what is this? 4, 5, I believe. Yeah. So now we know that a is equal to 1, b equals to 10, and c equals to 5. So we plug it in here. B squared is 10 squared minus 4. A is 1, c is 5. So this becomes 100 squared minus, this becomes 20. So 10 squared is also 100. 100 minus 20 should be 80. Do you see how this is positive? So this is, right, this is greater than 0. So this means it has 2 solutions. Okay? The discriminant is greater than 0. It has 2 solutions. Don't believe me? Let's just graph the function. So 5x squared. I just changed the letters, the variable b into x, plus 50x plus 125. Okay? It looks big, but wait, hold on, what? Is there only one solution? Really? Huh. Wait, hold on. Am I wrong? It says I'm wrong because look, it has one x-intercept, so you should have one solution. So I did this problem wrong. Let's just see where I went wrong. Hold on. Resume. Okay, I saw my mistake. This wasn't a 20. This isn't, look right here. It was my mistake right here. Like, I'm going to erase it. This was supposed to be a 25. All right. 125 divided by 5 is 5. So the C here is 25. So this 4 is going to be multiplied to, the C here was 25. This becomes 100. 100 minus 100 is 0. Yes. So if 0 equals to 0, this should only have one solution. Okay. That is the reason why when we graph it, take a look. Okay. We can graph 5x squared plus 10x plus, what is it, 25? Was that it? Yeah. 5x squared plus 10x. Yep. And look, zoom out. Wait. Hold on. Why is it only... Well, let's just graph the original. 5x squared plus, this should be 50, and this should be 120. Yep, perfect. You see? There you go. So that's my original, 5x squared plus 50x plus 125. That's my original function. You see how it only has one x-intercept? That's how you know it only has one solution. Okay? All right. Okay, I made that error so to show you to always graph it, to always double check your solution. Okay? Did that on purpose. All right, so this is already in standard form. So A equals to 1, B equals to 3, and C equals to 8. Plug it in. B squared gets us 3 squared minus 4. A is 1, C is 8. Okay, this becomes a 9 minus, this is 32. 9 minus 32, that looks like a negative number. That gets us negative 23. Unless I did something wrong. This looks like there's no real solution. I might have made a mistake, but looks right. Let's graph it. Let's see. X squared plus 3x plus 8. Yep, look, no x-intercept. So there are no real solutions. So I did it right. The discriminant here is negative, right? Okay, it's less than 0. It's a negative. No real solutions. Let's do the last one. The discriminant is very useful by telling us how many solutions there are. Okay. B squared minus 4ac is our discriminant. This is our in standard form. A equals to 1. B equals to 8 and C equals to 16. Plug it in, B squared, so it's 8 squared minus 4 times 1 times 16. Oh, this looks like 88 squared is 64 minus, oh wow, that's already a large number. Let's see, what is that? 4 times 1 times 16. Oh wow, this is, oh, this is negative 64. So this equals to 0. 0 equals to 0. There should be one real solution. So let's just graph this. This should only have one x-intercept. Okay, if we graphed it correctly, it should only have one x-intercept. So x squared plus 8x plus 16. Perfect. Do you see how there's one x-intercept? Okay, that proves that there's only one real solution, one root, because the discriminant here is equal to 0. All right, so there you go. That is how you use the discriminant to determine how many roots or solutions there are for a quadratic equation.